The test is on rational expressions and equations. I feel like this marker's going to die. So the first thing we talked about was how to simplify a rational expression. And they look like this. So the steps are to factor using the X method and to cross stuff out. Carl, you paying attention? Carl. Carl. You paying attention? Okay. We've got a lot of technology over there, buddy. Okay. So, to factor, you need factors of negative 32 that add to 4. What are two things that multiply to negative 32 and add to 4? Anybody, anywhere? Eight and 4. And we're going to put a minus on the 4 because it's a negative 32 and 8 minus 4 gets 4. So x plus 8, x minus 4. So when I'm factoring that bottom piece, I'm more than likely looking for a positive 8 or a negative 4 in those factors so that something will cancel. Just keeping that in mind. So factors of negative 72 that add to negative 1. What will we use? 7 and... Nope, 72. Oh, that's what you said. I'm going to use 8 and what? 9. So check out, I have a positive 8 and a negative 4 up here. I'm willing to bet that the positive needs to be with the 8 and the minus needs to be with the 9, just like you said. Because I'm looking for something to match so that I can cross it out. We're going to cross out those x plus 8s that match. So then the answer that's left is x minus 4 over x minus 9. So that's the first thing we learned in this unit. All right. After we learned about simplifying, we went on to multiply. And it's basically a simplifying problem on steroids. So there's just a little more to do here. I can't do anything with that. It's just a number. It's just going to hang out up there for a while. I will be able to find factors of 27 that add to negative 12 and factors of 81 that add to negative 18. On the bottom here, we'll find a common factor that we can divide out. So I want you to take just a minute and think about those, and I'll ask you for your input. Alright, so what are two things that multiply to 27, add to negative 12? Three more? Okay. And what's special about them? They both negative. Because that's a positive 27. They're both going to have to be the same sign. So x minus 3, x minus 9. And that negative 12 is what gave it away. What multiplies to 81 adds to negative 18? And? Okay. 6 and 54 have a greatest common factor of 6 that I'll be able to divide out. Let me write this down first. So they have a common factor of 6. So when I divide that 6 out, that becomes 1x minus 9. Lots of minus 9 in this problem. Alright, so I'm looking for those matches. What matches? Boom, 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 boom. What else? Yep. Alright, so everything on the top of our fraction has canceled, but that does not mean there's a 0 up there. Like 6 divided by 6 is a 1. So we still have to hold the 1 down on top, and the x minus 3 has to stay in the denominator. That doesn't happen a lot, but it's worth seeing. Y'all okay? Okay, continue. The next thing we learned about was division. We're going to divide. And this is when we learned about keep, change, flip. Nine over x plus 3 divided by 9x plus 81 over x squared plus 13x plus 36. So to begin, we're going to rewrite the problem first. So I keep the first fraction the same. I change division to multiplication, and I flip this back fraction. So x squared plus 13x plus 36 comes to the top, and 9x plus 81 goes to the bottom. Now we're going to factor and cross stuff out. I'm going to keep 9, x plus 3. None of that can be factored or changed in any way. What are factors of 36 that add to 13? Anybody? 4 and 9. Come on, Zoomers. What do 9 and 81 have in common that I can divide out? Zoomies. You there? Hello? 9. Thank you. So when I divide out 9, I get 1x plus 9. Alright, so what is going to leave us? X plus 9? One more thing. 9. So on top, I got an x plus 4, and on the bottom, I got x plus 3. Y'all should go tell your grandma you can do that. She might give you $1 or a quarter. Maybe $5. Some people got rich grandmas. Alright, so after division, we learned about adding. And I'm just going to go ahead and skip to the making a common denominator examples. So we're not able to add until we make a common denominator. On this side I've got 5x, and on this side I just have x. So we're going to multiply a 5 to this fraction in order to make those match. And whatever I do to the bottom, I must do to the top, keeping in mind that I will have to distribute that 5 to both of those terms. So 6x over 5x plus, this becomes 15x minus 5 over 5x. And now I can combine like terms across the top. 6x plus 15x is 21x minus 5. And then I just bring that common denominator over. Don't add those together. Yay, hooray. How's that going? Okay. after addition, we talked about subtraction. This is a great piece of paper. And subtraction is not all that different from addition, other than the negative that hangs out in the middle. So I've got 3 over x minus 5, take away 8 over x plus 4. I will need to make a common denominator. Sorry, messy. And I have to use both x minus 5 and x plus 4. I can't just multiply a 4 on this side and a negative 5 on this side. It's because this is a minus 5 and a plus 4. I have to use the whole thing. So this side gets x plus 4. And I will distribute. So I get 3x plus 12 over x plus 4 . I've got to watch this negative. I want to attach it to the 8. So I'm going to make it a plus here and just move it onto that 8. It will need to get distributed with the 8 when we distribute. So I'm going to put an x minus 5 on this side. Negative 8x plus 40 over x plus 4 x minus 5. Alright, so once you have that common denominator, you can add across the top. So I'm combining like terms. Three x take away 5x is negative 5x. Or sorry, 3x take away negative 8x is negative 5x. My brain was working faster than my mouth. 12 plus 40 is 52 over x plus 4. X minus 5. Yeah? Good with that? Alright, the last style of problem we saw, we started working on Monday, was solving. And it looks like this. 2 over x equals 5x plus 20 over 2x plus negative 1 over 2x. So this is a little bit similar to what we do when we're adding and subtracting. We're looking down at the bottom at what's in the denominator. and I see x, 2x, and 2x. So at the very least, I see a 2 in some of them and an x in some of them. And I don't need to combine them and make more. I just see 2x. So I'm going to use it to multiply to each of those fractions. So we're going to multiply 2x to each fraction. I do this to cross out the denominators. So on this fraction, x and x cancel. 2 times 2 is 4. On the next one, 2 and x cancel. On the last one, 2 and x cancel, leaving me with negative 1. I'm going to combine like terms on the same side of the equal sign. 20 minus 1 is 19. I'll then subtract 19 from both sides. Negative 15 equals 5x. And divide by 5. X equals negative 3. These are all of the things that we have seen